Welcome to the world of computer vision, where machines see, analyze, and interpret the world just like humans. From AI-powered surveillance to self-driving cars and medical imaging, computer vision is transforming industries and revolutionizing how we interact with technology. In this video, we'll explore the fundamentals, applications, and the latest advancements in this exciting field. Let's dive in. Computer vision is a field of artificial intelligence, AI, that uses machine learning and neural networks to teach computers and systems to derive meaningful information from digital images, videos, and other visual inputs, and to make recommendations or take actions when they see defects or issues. Computer vision is used in industries that range from energy and utilities to manufacturing and automotive, and the market is continuing to grow. It is expected to reach $48.6 billion by 2022. How computer vision works. Computer vision needs lots of data. It runs analyses of data over and over until it discerns distinctions and ultimately recognizes images. For example, to train a computer to recognize automobile tires, it needs to be fed vast quantities of tire images and tire-related items to learn the differences and recognize a tire, especially one with no defects. Two essential technologies are used to accomplish this: a type of machine learning called deep learning and a convolutional neural network, CNN. Machine learning uses algorithmic models that enable a computer to teach itself about the context of visual data. If enough data is fed through the model, the computer will look at the data and teach itself to tell one image from another. Algorithms enable the machine to learn by itself, rather than someone programming it to recognize an image. A CNN helps a machine learning or deep learning model look by breaking images down into pixels that are given tags or labels. It uses the labels to perform convolutions, a mathematical operation on two functions to produce a third function, and makes predictions about what it is seeing. The neural network runs convolutions and checks the accuracy of its predictions in a series of iterations until the predictions start to come true. It is then recognizing or seeing images in a way similar to humans. The history of computer vision. Scientists and engineers have been trying to develop ways for machines to see and understand visual data for about 60 years. Experimentation began in 1959 when neurophysiologists showed a cat an array of images, attempting to correlate a response in its brain. They discovered that it responded first to hard edges or lines, and scientifically, this meant that image processing starts with simple shapes like straight edges. At about the same time, the first computer image scanning technology was developed, enabling computers to digitize and acquire images. Another milestone was reached in 1963 when computers were able to transform two-dimensional images into three-dimensional forms. In the 1960s, AI emerged as an academic field of study, and it also marked the beginning of the AI quest to solve the human vision problem. 1974 saw the introduction of optical character recognition, OCR, technology, which could recognize text printed in any font or typeface. Similarly, intelligent character recognition, ICR, could decipher handwritten text that is using neural networks. 4 Since then, OCR and ICR have found their way into document and in voice processing, vehicle plate recognition, mobile payments, machine conversion, and other common applications. In 1982, neuroscientist David Marr established that vision works hierarchically and introduced algorithms for machines to detect edges, corners, curves, and similar basic shapes. Concurrently, computer scientist Kunihiko Fukushima developed a network of cells that could recognize patterns. The network, called the neocognitron, included convolutional layers in a neural network. Computer vision applications. There's a lot of research being done in the computer vision field, but it doesn't stop there. Real-world applications demonstrate how important computer vision is to endeavors in business, entertainment, transportation, healthcare, and everyday life. A key driver for the growth of these applications is the flood of visual information flowing from smartphones, security systems, traffic cameras, and other visually instrumented devices. This data could play a major role in operations across industries, but today goes unused. The information creates a test bed to train computer vision applications and a launchpad for them to become part of a range of human activities. IBM used computer vision to create my moments for the 2018 Masters Golf Tournament. IBM Watson watched hundreds of hours of Masters footage and could identify the sights and sounds of significant shots. It curated these key moments and delivered them to fans as personalized highlight reels. Google Translate lets users point a smartphone camera at a sign in another language and almost immediately obtain a translation of the sign in their preferred language. The development of self-driving vehicles relies on computer vision to make sense of the visual input from a car's cameras and other sensors. It's essential to identify other cars, traffic signs, lane markers, pedestrians, bicycles, and all of the other visual information encountered on the road. IBM is applying computer vision technology with partners like Verizon to bring intelligent AI to the edge and to help automotive manufacturers identify quality defects before a vehicle leaves the factory. Computer vision examples. Many organizations don't have the resources to fund computer vision labs and create deep learning models and neural networks. They may also lack the computing power that is required to process huge sets of visual data. Companies such as IBM are helping by offering computer vision software development services. These services deliver pre-built learning models available from the cloud and also ease demand on computing resources. Users connect to the services through an application programming interface (API) and use them to develop computer vision applications. IBM has also introduced a computer vision platform that addresses both developmental and computing resource concerns. IBM Maximo Visual Inspection includes tools that enable subject matter experts to label, train, and deploy deep learning vision models without coding or deep learning expertise. The vision models can be deployed in local data centers, the cloud, and edge devices. Image classification sees an image and can classify it: a dog, an apple, a person's face. More precisely, it is able to accurately predict that a given image belongs to a certain class. For example, a social media company might want to use it to automatically identify and segregate objectionable images uploaded by users. Object detection can use image classification to identify a certain class of image and then detect and tabulate their appearance in an image or video. Examples include detecting damages on an assembly line or identifying machinery that requires maintenance. Object tracking follows or tracks an object once it is detected. This task is often executed with images captured in sequence or real-time video feeds. Autonomous vehicles, for example, need to not only classify and detect objects such as pedestrians, other cars, and road infrastructure. They need to track them in motion to avoid collisions and obey traffic laws. Content-based image retrieval uses computer vision to browse, search, and retrieve images from large data stores, based on the content of the images rather than metadata tags associated with them. This task can incorporate automatic image annotation that replaces manual image tagging. These tasks can be used for digital asset management systems and can increase the accuracy of search and retrieval. And that's a wrap on our journey into computer vision. Whether it's helping doctors detect diseases, enabling robots to navigate, or powering next-gen augmented reality, the potential is limitless. If you found this video insightful, don't forget to like, subscribe, and hit the notification bell to stay updated on the latest in AI and tech. Drop your thoughts and questions in the comments. We'd love to hear from you. Thanks for watching, and see you in the next video.